Alright, here we got TIA Portal version 15. I'm working on a S7 1200 PLC. Today I'm going to teach you guys about how Siemens, how they set up their user-defined data type and how to use sequential shifting to make a step-by-step shift bit go from left to right. Basically, for example, bit 0, bit 1, bit 2, bit 3. Unlike Allen Bradley or Omron, which a word is 16-bit, Siemens, they use 8-bit per word. So if you notice, their actual input output, it only goes up to 8 or 7, I guess. Well, really 8, but 0 is always the first bit. Then 7 is going to be the 8-bit. So you got 0, 1, 2, 3, 4, 5, 6, 7. So you're going to have a total of 8. And I don't know why, but Siemens only have 8-bit per word. Really, it's just the byte, because byte is 8 bits. A word, a real word, will have total of 16. So, and that's for actual peripheral IOs. But for integers and stuff like that, yeah, you're gonna have 16 memory bits in it. But I'm gonna show you guys how to set a user-defined data types. Then you have to make a new data block to use that, so you could use it in your program. So, for example, I'm gonna show you right here. You see I have my own data block right here. I have a word to shift, and my data type is going to be a word. I have an array right here, but I'm not using it at the moment. That will be for another video. So we have the main OB right here. Let me open it up and let me go online. And what's really cool about this is I have a network that I'm using for my Omron and Siemens PLC. I can connect to any of them wirelessly because I got them all on under a Ethernet IP setup communication protocol, and all of them are under the same subnet mask, and they're pretty much the same IP address. So I can pretty much connect them wirelessly, and right now I'm not using any wire to connect them. So that's pretty cool. I could teach y'all how to do that in the future, but for now, let's just check out how we do this. Alright, this is one of the unique way Denso taught me how to use shifting sequential shifting register. You have to shift left right here. And normally, how people do use this is they will have like a bit right here, and they will put a positive trigger right here, and every time this comes on, it will shift it one time to the left. Then this will have to come on again, do it again, shift it again, shift it again to make it keep going higher and higher and higher. But the way Denso uses the shift is whatever word that you use to shift it, you use that word itself to keep shifting the whole word that you're shifting. For example, I'm going to start at bit 0 right here, x0, and the main word is word to shift at bit 0. So when that comes on, it's going to turn on this timer down here. So it's going to be on for 2 seconds. Once it's after 2 seconds, it will basically enable it, and it's going to shift one time. Then it will jump from 0 to bit 1. Then bit 1 comes on, After 2 seconds, then it will enable it. Then this will change the bit 2, and this will comes on, and it'll go on and on and on. And this is a unique way of doing it. Siemens and Omron's instruction manual does not teach you how to use like this. This is really for experienced programmers. This is one of the ways that you kind of have to work with the individual company to learn how they use it. And this is one of the unique ways that I learned from the engineers and programmers at Denso of how to use it efficiently. Normally, you won't have any of this stuff right here. Normally all you have is just these two lines. Then something's gonna keep making this comes on and off, and that's not really efficient because you're gonna have to write extra logic to keep shifting it. But if you do it like this, pretty much the block is gonna shift itself. And what's good about this shift left is there's a lot of things you can use it after this. Let's say after this bit 0 is on, I can make this do something. Then when that's done, bit 1 comes on, make that do something. And that's really how automation works. You have sequential order. So let's start it up. I set this up in a way to make it go all over and over and over, but after 100 times, when it hits the last bit, which is bit 8, and in a 16 bit format, that will be 80, pretty much in hexadecimal. So after the hexadecimal 80, that will basically reset and go back to bit 0. So, and if you don't understand it, it's just like this. You have a word right here, and look at this hex right here. You see this hex? So this first bit, it will be a 16 format, 16 hexadecimal format. You will put a 1 in it, it will turn on bit 0. And bit 2, it will be 2. Bit 3, it will be 4. Bit 4, it will be 8. Then go to the bit 5, it will be 10. So it will keep going until you hit the last bit, which is 80. That's how you start the shifting. So if you can see it from here, I am moving. When I activate this bit, it's gonna have a positive trigger, and I'm gonna move 16 hexadecimal 1 into the data block work to shift. So when I enter 1 in here, this bit comes on and the timer will start. Alright, let's give it a shot. Turn this on. Turn that on. You see how it comes on? 3, 4, 6, 7, then reset. So just see this number, and you see how it's 1, and that's 2, 4, 8, and 10, 20, 40, 80. So that's how you pretty much do the shift left or shift right register. And this is a very efficient way you could use it to track products in conveyor. You could make it do multiple things, like using a lot of pneumatic air. You can make the pneumatic air cylinder go forward. Then you can make it grab parts. And then step 3, you can make it retract, pull the part back. Step 4, you can make it go, put it on the holding jig. Basically just however you need the bits. That once it's finished, then the whole transfer can go from left to right. Then once it hits the sensor that is in place, then just restart the shifting. Then it will just do the steps all over again. And I have it to right here. If this thing goes over 80, and you know this bit M70, which comes from right here, if I'm at M70 and it's over 80, it's gonna move 1 back to the data block word to shift. Now this is my user defined data right here. I have to create my own user data block, a data type under here. You can't use Siemens internal memory like the M bits. Those are Siemens internal memory, and if you use them, they will not shift properly. For some reason, Siemens internal memory does not really register itself as a word. Like let's say MW0, right? You would think it'll let you use 8 bits in that MW0, but for some reason those internal bits from Siemens does not really perform like an actual word. I think it's because you're not really supposed to use those M bits for stuff like that. It should be really for Boolean type of word. Like you could use it as an internal bits to turn things on and off. But if you want to use it as a word or a double word, you kind of have to make your own data type to make it work. Because I try to use MW0 or MB0. It'll go to 1, then 2, then it'll just go back to 1. So I had to create my own data type and make a data block for that so I could use it. So basically how you do that is let me go offline. You go to the user data type, you add a word. So I'm going to add mango word. Then I will say this will be a word. Well, let's just make it let's make it a byte. Okay, so that will be mango word. Then I will have to go to my program block, add a new block. I will have to say data block right here. Then what type of data block will this would be? I'm going to say mango block. Then I'm going to have to use the user data type right here. Let's say OK. Once you say OK, you can start using these in your program. So now I could use right here, I could say, I'll use some Siemens internal memory. I'll say M100.0. Once that comes on, then I will move. I will move I'm a hexadecimal 8-bit. I will use B pound 8 pound, and I'll move in 1 into Mango's word. You'll have to say your data block first. Mango block, you see that? This is the data block that I just created. Once I enter that, then you can see the word in here, and I'll say mango word. And once you get that, 1 will be there. Now, what's cool about Siemens is you can use the bits in the word. Siemens call it slice programming. For example, if I want to use the first bit in mango block on the mango word, you just say mango block. Alright, then mango word. Type it exactly as you say, got it. Save. So I say mango word right here. Then after that, just put period. Then you will do percent x0. Not percent, I'm sorry. Just do x0. See how it's not red or got a bunch of underlined stuff? That means you could use it like that. Meaning I'm using the first bit in my Mango word. So once that comes on, let's say I want to turn another bit on, right? So once that comes on, they turn on bit 1 from the Mango word. So once that comes on, put the same memory bit in there. This comes from here, remember that. When that comes on, then turn on my Mango word bit 0. So use the Mango block dot Mango word dot x1. There you go. Let's try it out. Download it up. Initialize. Okay. Alright. So if I turn that on, it will move one, that comes on. When this comes on, it turns on that one. So this is one of the ways you could use a word, but you could control the bits inside the word. That they call that splicing. So that's for that. But as for the shift register, just remember this is how you want to use. Whatever you're shifting, you want to use those bits to turn on the register to keep it shifting. So I hope y'all understand what I'm trying to say here. If it's kind of confusing, don't worry about it. The only way to really understand this thing is if you actually have a project that you're working on. I mean, that's how I learned. So if y'all got any question, if you want to learn more about it, you can always hit me up. But in the meantime, that's all I got for today. I mean, I can even show you Siemens, Omron, the same way how I shipped it. Let me hook it up. Let me go online to one of my 3 PLC I got hooked up. I think it's on the IP address node 10. Yeah. Node 10. Let's connect that. Yes, transfer everything. And this is for my shed, my work room. All of the logic that I wrote I started from scratch. And I used one of my I have 3 LED buttons outside, and whenever I lock the door, I want to have some kind of confirmation to show me that it's locked. So what I did was I made the shift register. I'm gonna call it ASL. Once I lock the door, I want the LED to blink from left to right. So that's pretty much what I did. Once the door is locked, then it'll shift left to right to make the LED turn on one at a time from left to right. And I have those LED lighting up straight in a row. Alright, so let's go to the ASL or shift register right here. Alright, so you can see how it's not on right now because the door's not locked. But whenever I lock the door, and it's under the interlock, meaning the interlock means it's I guess you can call it a master control relay, where it will not, nothing between interlock and interlock clear, nothing between that and here. All of this program inside will not work unless, you know, this is active, or all of this is on. So once all of this is on, then all of this will start working. And once I lock the door, so basically I'll have the locker. My air lock is forward for the top one. The second one is forward. Those are the auto switch sensor. Make sure it's confirmed forward. Second one, make sure it's confirmed forward. And once that's done, then basically start all of this over here. Oh, right here too, I have a required condition for the ASL. This rung is the interlock condition that starts the LED blinking like a screensaver. So if the door sensor is not on and all of this data match, then I'm gonna move a 1 into H10. So it's the same scenario. You're moving a 16 format hexadecimal into 1, and always remember, you know, a word, a byte, a double word, they all have data that consists of hexadecimal format. You have hexadecimal format, you have integer, you have unsigned integer, you have signed integer, but hexadecimal format is the most efficient way to control Boolean bits inside a word, double word, you know. So this one will be a 1. You know, you want to turn on all this 4, it will be an F. If you want to turn on, you know, just those 2 or 3 will be D0, and this is hexadecimal format. So that's how you pretty much control bits inside a word. So you can see the same format and see how all this line up like this, and the word inside H10, the bits inside H10 is what's gonna keep it shifting. So I hope you guys understand. Hit me up if this is confusing. I'll try to break it down better next time. Alright.